I welcome you all for this presentation. In this presentation, we are going to discuss about transposition or permutation techniques. This is the overview of this presentation, introduction to transposition or permutation techniques. Then some of the transposition techniques like rail fence cipher, row transposition cipher, then block transposition cipher. Then we are going to discuss about product ciphers. Then some practice problems related to transposition cipher, followed by summary of this presentation. So what is the need for transposition or permutation cipher? So far we have discussed some of the substitution techniques and we have analyzed, performed cryptanalysis also with those substitution techniques. So why we need transposition or permutation ciphers in this sense? In order to hide the messages by rearranging the letter order. There in the substitution technique we substituted one alphabet with another alphabet. But here we are just rearranging. So whatever the values in the plain text, that is in the cipher text, but the position is changed. That is the difference between substitution techniques and transposition techniques. But here we are not altering the actual letters, just we are shuffling it or rearranging it. So we can recognize these since have the same frequency distribution as that of original text. These techniques are also vulnerable to some attacks because anyway those letters are there, we need to rearrange. That's it. Next is the rail fence cipher. This is a basic transposition cipher. Here what we are doing is we are writing the message letters diagonally over a number of rows. Then we are reading off the cipher row by row. So why the name rail fence means we know what is a rail. So here it is just like a railway fence. So only fence is for security. The compound structure only we are calling it as a fence, right? So it is just like a railway fence. So only here the name rail fence cipher. So how we are writing is plain text meet me after the Togo party MEET. This diagonal way we are writing. Then after finished writing we have to read it row by row. So here we have to read MEMAT, MEMAT. This way we have to read it. This green line you have to look into. Or writing you have to write diagonally. The red line you have to look into. And for reading you have to see the green line. Row by row we have to read. It is a very simple cipher, transposition cipher. Here you look into the plain text as well as the cipher text. Both are having the same alphabets only. Only thing is the positions are changed. It is permuted or it is shuffled, rearranged. That only happens here. So only the name transposition cipher. Next is the row transposition cipher. This is another method of another transposition technique. It is a more complex transposition technique. Here what we are doing is we are writing the letters of message out in rows over a specified number of columns. Then we are reordering the columns according to some key. There we just call a row by row we read. Here based on some key we are rearranging again the column, then we are reading off. The same the plain text is attack postponed until 2 AM. Here the key given is 431257. So we have to divide the given plain text into 7 blocks. So here attack postponed until 2 AM. Then here we are having 3 blank spaces. Those 3 blank spaces are filled with some fillers. Here this is important. You have to fill it with fillers. Then what we are doing is the column out, the key you have to write 431257. Then whichever is the first value 1 TTNA, this green box you have to look into. Then 2, it is a blue box APTM. Then 3, this is yellow box TSUO. Then 4, purple box AODW. Likewise we have to convert the plain text to cipher text. Here also what happens, the same plain text alphabets are there, only the position is changed. That's it. So this is also a transposition cipher. Next is the block transposition cipher. Here it is a arbitrary block transposition may be used. That is, we can specify the permutation on the block and then we can repeat each block of the plain text. It is somewhat similar to the previous only. Here also we are having a key, but there what we did, we have written everything in row wise. Then we have read column wise based on the position of the key. But here as such the plain text is given. We are not writing it in a row wise as such it is given. Then here we are just splitting into different 9. Here 0 to 9 is there. So 10 blocks we have to split it off. Then you have to apply the key 4 9 3 1 2 5 6 7 you have to apply. And based on the position, first we have to take the fourth position first. Based on the 4, there 4 means that 4 we are taking. Here whichever is there in the fourth position, so 0 to 9 we have to write, and whichever is in the fourth position that has to come first. C is in the fourth position, so C. Then 9, T is in the ninth position, so this T. Then 3 means which one? A is in the third position, so this A. Likewise, based on the key, we have to find the position of the ciphertext. Here also, the same alphabets in the plain text is there in the ciphertext. Only thing, the position is changed. So this is also a transposition cipher. And here also you have to fill with some fillers. Based on the key size, you have to divide or split the given plain text into different blocks. And at the last block, if there is any filler required, means we have to fill it with a filler. This is a block transposition cipher. Next is product ciphers. Product ciphers in the sense, so far we have seen substitution, transposition. Product cipher means combining to substitution or combining to transposition or hybridization of substitution and transposition. That is the product cipher. So ciphers using substitution or transpositions are not secure because of the language characteristics. So we have to consider several ciphers in succession to make order. So what is our main objective? Security is our main objective. So how we are designing the cipher in a very complex and secure manner. As the complexity increases, security increases obviously, because what we need, the cipher was not must not be broken by any attacker. That is our ultimate thing. So we have to make it a harder likewise. So how to make the cipher harder? For that, what we are doing is 2 substitutions make a more complex substitution, then 2 transpositions make a more complex transposition, but a substitution followed by a transposition makes a new much harder cipher. So the classical cryptography we have discussed only substitution, transposition. So we are just merging this classical to the modern ciphers by having this substitution followed by transposition. So we have discussed many classical cryptography techniques. Next we will be discussing in the coming units the modern ciphers. So this is the foundation for the modern ciphers. So here I have given you 2 problems to practice based on the transposition cipher. Whatever we discussed, rail fence, row transposition and blocks transposition. I request all of you to practice these problems. So in this presentation, we discuss about introduction to transposition or permutation ciphers. Then we discuss 3 transposition ciphers like rail fence cipher, then row transposition cipher, then block transposition cipher. Then we discuss about the product ciphers and what is the need for going in through modern ciphers. We so far discussed classical ciphers, why we are switching on to modern ciphers. That motivation we have seen. In the next class onwards, we will be discussing about the modern ciphers. Thank you.